In a good programming language, you can use essential math easy and intuitively to ensure high productivity and precise calculations. Minecraft, on the other hand, does this very complicated. This simple equation would be this bulk of code here, with many repeated scores and unclear scoreboards, despite the fact that writing scoreboard players all the time takes a long time. With objD, I wanted to find a good solution between both approaches and make the entire system modular. With the Scoreboard widget, you can define a scoreboard just with one argument. It would automatically add the scoreboard into your load function and assign the dummy type. However, you can change the type easily with the type argument and also disable the load function by setting add into load to false. Here you can also change the display text component here, but usually you don't have to define any scoreboards whatsoever because the simple Score widget would do this itself. As a score, objD defines a combination out of an entity here, and a scoreboard name. This would be a string here. As third optional argument, you have the add new here to interrupt the automatic addition to the load file again. Let's have a look how this works in code. We define a score here, and as said, we need an entity here, so let's choose the entity.all and a scoreboard name, score1, and we can run this whole thing here. And when we take a look at the main.mc function, there is nothing because we just defined a score. In the following steps we have to actually calculate with this score. What you can see is in the load.mc function, this score1 is added as dummy, and you don't have to care about it. Just use the score anywhere in your project and it is automatically defined in the load.mc function. Then there are a few methods here. On this. So to add some interactivity to this score, there are a lot of methods here. These methods here should be self-explanatory. We can use these to do simple math with numbers. So for example, we can use the set method here and set it to a value, let's say 4, and we can see in our main.mc function the scoreboard players command is generated here. I would also recommend to save these scores here in a variable. So let's do that. Score1 equals our score here. And then we can use our variable multiple times in our actual generate function down here. And everything is depending on this one score variable here, and we can change it, and everything in our project changes. So now we can repeat that and also add something with the add method. And actually we don't really have to repeat this. We can just put it at the back of our set, because the set method actually returns a new instance of this score here that has the set applied. And on this instance we can add another instance, for example with add. So we can see in the main.mc function this remains the same. We can stack all of our methods here. All of these methods here are a bit more interesting because they do the actual math and compare two scores. So in our main.start we can define another score, let's name it score2. And on our score1 we can, for example, say set equal. That will set the score1 to another score. In our case this would be score2. And this would generate this scoreboard operation command here. In my opinion, this is much clearer here. Again, we can stack these methods here and for example, subtract a score, and you can see it generates all the commands for this. These are all the comparison methods. You can read more about these in the official documentation. Last but not least, we have these data extraction methods here, and these actually generate an execute command. Another big bottleneck were constants in scoreboards. objD also handles that, and you can just give it a value like that. and it creates a scoreboard called objD const itself and assigns your value to a fake player here. And of course you need a way to test if a score has a specific value. You can do that with all of these methods here. Their behavior should be self-explanatory, is pretty similar to the Minecraft way up here. And the method names explain it quite well. And we can use these conditions, for example, in an entity selector, like that here with the scores argument. Here the fromSelected constructor is used to make the entity.selected unnecessary in the arguments here. Or you can also use it in combination with the if widget here, and then execute a list of other widgets. You can learn more about the if widgets and conditions in this video once it is out. Also head over to the official objD documentation at stevatus.com/objD/documentation to gain more information about scores.